So thread is nothing but here piece of process. Whenever we are going to do some task, the task is not a smaller one, it's a big one. So to achieve that big task, we need to make the task into some smaller tasks. So each and every smaller task is called as a thread. See here, right click on the task manager, select the task manager processes. How many number of processes that are running internally? All these things are called as threads. So this is one process, this is one process, and we have a operating systems, single thread operating system, multi-thread operating system. The difference is we can run more than one process at a time. Here, first zoom priority 12, next 13, next 11, and again 12, 9, 12. So it is keep on changing its priority. That means internally how many number of processes that are working on it. So DWM is goes to first priority, and again it will be goes to second priority, and task manager we are not executed anything. Now zoom is becomes a 0. Again it will be goes to first priority like this. So it is shuffling, means for us 1 second is important, but for system milliseconds are important. So 1 second is equal to 1000 milliseconds. 1 second equal to 1000 milliseconds. So at a time it can process internally 1000 processes. Now here we are going to do thread application in C#. So whenever you have written methods, till now to create a method, we know two types. One is by using object we can call. Number two, by using class we can call. Now here, these methods we can point into with the help of a delegate. And now here is thread. That means parallelly you can run many methods at a time. So methods will run parallelly. So here this is going to continuously with some span of time. So that means what we have 4 processes, means 4 tasks. So first priority method 1, and the second priority method 2, and third priority method 3, and fourth priority method 4. And again after that depends on the method how much time it is consuming. Internally you already have about something like shortest job first, and first come first serve, last in first out. These are all internal algorithms are there. So it depends on the time internally the operating system will take, which one is important to them, which one they are making as pause, and which one they are continuing. It is going to search internally. And we need to understand thread life cycle. First we need to create a thread. Thread means we are going to divide the programming into our own choices. In this thread we have to create the thread, and then start the thread means assign the method to the thread. And if you want to stop at the middle, then we can say something like sleep. How many number of milliseconds you want to stop the process. And again resume. Whatever process already sleep, we will be going to continue the process. Resume. And you don't want to continue the process, you want to stop it. Abandon. You want to stop at the middle of the interruption, or you want to proper at the end. So this is start the thread, sleep the thread, resume the thread, abandon the thread, stop the thread. This is what we call it as thread life cycle. It's very important interview question. So what is a thread and what is a thread life cycle? So thread life cycle, first we need to create the thread. Next we can start the thread, sleep sometime. Again, if you want to continue, continue. And middle of the interruption, abandon. And the last, finally, we can stop the thread. By default, every process, whatever methods we are doing, those are all single threaded applications. Single means only one thread, one process. Multi-threading means multiple processes will run at a time. That is what we call as multi-threading application. So now we can see here thread is a like a process and which can be flow of the control and it is going to performing lightweight process. And we can observe in the task manager networking performance. So how much busy your RAM? Sometimes we can open audio files and video files and some other applications like .NET, Google Chrome, Skype, all the things. But our RAM capacity is 2 GB RAM or 4 GB RAM. It is fully loading so that it is very complex to load all the applications and that applications to be executed, it will take more life cycles. And the resources, what are the resources internally it is taking, all the things we can observe. So at present explicitly user is open June. It is taking the first priority. And the remaining thing internally in the background it is working. And here how much time it is taking and what is the total size it is allocating, 28 MB. And this is in the network, it is allocating the memory of 1 Mbps and this is 60 seconds. And if at all any network related connections it is taking internally, all the things we can monitor. It is purely for network administrative purpose, but we have to know every second any new services are coming because sometimes systems are hacking and all. Is there any unknown exe file is running in the background? Everything we can monitor from here. And sometimes we can assign the port number also. At that time, if that port is assigned to any other process, we can identify here. System default port number is 80. And if we are going to assign any programmatically port number, we can check here. Already the ports are assigned to, these are all the background processes. So we can take another number for processing. Let me give it. If in a program we can mention any 5353 port number, it will not work because it is already assigned to the team leader. So these are all the list of processes we can check in the system. So here how to make the thread, how to create the thread. This is for this we need to use one namespace, call it as system.threading. This is a namespace. And create the thread here. Thread is a class, object name equal to thread.current thread. You can give any name, just th.name, main thread, and display the name, th.name. So now we created one console application. Using system operating and run, we can observe the difference between without a thread and with the thread. This is the main thread. Now we can see 1000 milliseconds reduced to 1 second or 2 seconds. It will not come. After 2 seconds, that process is executing. After 1 second, so internally they are going to start the processes like this. First 2 seconds after, first line will come. After 1 second, then again this will come. So this is a simple thread implementation. If you are going to give, the process should run from somewhere else because our server is in US or UK or some other location, and we need to get the data from here to there every time without giving the button to the server. We have to make some pause and again should start. Parallelly, it will establish the connection and bring the information. What are the properties? Current context, which thread you are executing, culture, because we have a Telugu language, English language, Hindi. This will become in ASP.NET. I will show you. So the content, whatever we are projecting on the page, that will be displayed in different languages. The current culture will become under threading, and the principal, what is the role? This will be comes under security. You are voting as a user. Are you a admin? Do you have a rights to access the applications, or you are a normal user? Because whenever we are logging onto the system in any company, they are giving different logins. One user can install the softwares, but one user cannot install the softwares. So which one we can use at that time? Role-based security. Role means who is the person who is logging into the system. Depends on the roles, they can perform the activities on the PC. Just now we executed currently running thread. So this culture will come here, universal interface culture. We have to create one separate file, all the languages, what word equivalent to what type of text is coming, depends on that the text will be displayed. And it is for execution context. Current thread will be executing or not, we have to display the information. Still is alive, true. True means it will run. Is a background process, whether it is running or not, we have a control called as background worker process in C#. So then internally it is associated with the service. We can identify whether this is running or not. In Windows services we have seen services.msc. From the network admins, they can observe that what type of processes are already running in the background. That they can monitor by using is background process is working, yes or no. So it is a thread pool. Pool means not only one thread you are created in your program, you have many threads, then is this thread pool, indicating whether it is belongs to a pool or it is an individual. By default, how many number of requests we can give at a time? 100 requests. For every second, it is going to, we can assign 100 threads. Management thread here, unique identifier. You can give for ID for this threads, then we can get the process. Just now we used name of the thread. Priority. We have many threads. Take this one as first priority, priority equal to 1. Take second priority, third priority like this. This is thread state. State means is it is a running state, or is it is a sleeping state, or it is a resume state. We can identify. So these are all properties. And just now we have used method. These are all begin thread affinity. To execute the instructions depends on the identity of the operating system. And remember that these will be completely under the control of operating system. Now we will see for loop thread dot sweep. 1 second. Console at right line. Fine. We will do one. Now run it. First 2 seconds, next 1 second. Now every 1 second it will become. And we close at the middle. Now again we can start. And already random number generation. We don't want these numbers. We want random numbers. Random. We are receiving the Google number for by web login or any other some secureable sites. They are going to send a number to our mobile device. Starting number, ending number. You can give like 4-digit number, 5-digit number, the range. We want 5 numbers. First 2 seconds, one process, again 1 second, one process, again every 1 second it is going to start. Next random numbers will generate. In the right line is right. Observe that every number is not same. Automatically it is creating different numbers. Okay. And not only numeric numbers, if you want to generate any alphanumeric digital number number, we have a GUID, global unique identifier, new GUID. It is for whenever we are installing any operating systems or you want to upload any software, type the above key, something like that. At that time, it is generating some biggest number. because already we know the process and commenting. So what is the number it is generating? You can see it. This is alphabets, digits, hyphen, alphabets, digits, hyphen, something like that. And it will be going to give depends on 32-bit or 64-bit number. Now we need to make this one as substring. We don't want that many. We want from 0 to 6, first to 6 characters. So it is going to give like this. And every time first is 74C90B. And again you can run it. 46FDC6. And again you can run it. 43A3D. This is for while you are going to register the websites and all, we are going to enter the above code. Every refresh, it is going to generating the new code. So that code will be going to come under GUID, Global Unique Identifier. So these two are very important for interview purpose. How to create a random numbers with a numerical and with alphanumerical. Random will give only numerical values, and here is UID, Global Unique Identifier, will give alphabets with numerics combination. And by default, it will give 32 or 64-bit. And whenever you want only the 6 digits or 10, depends on that we can give. And it is a starting number, and it is number of digits you want. So if you want 8 or if you want 10, we can say 0 to 10. Or if you want 10 to 20, the starting index is 10, and from there to you want it 10. But it will be going to define here. So 8, this is first, hyphen, again 8, hyphen, again 8, hyphen, and so on will come up to 64. So this is here, the begin thread. These are all the regions. So these are all the things are not used for programming. It is completely for network related programming. So this we will use. One is for start the thread explicitly. We have to make a thread dot start sleep. How many number of milliseconds you want to sleep it, and the spin wait. You can wait the number of times for I equal to 0, I less than 10 while you are going to iterating, and we have to apply after 5 iterations stop it. Then we can say spin wait. And this is for volatile reading. Whenever we have a address means till now we are not using any images in a binary formats, and if we used binary format, that information, if the same information is again repeating, don't calculate again. Automatically you have to volatile the memory and read the data for byte values, for double values, for integer values, for object values. So different type of processors of your computer is going to take these values as a cache. Cache means remember the same information earlier, you have to substitute again. This is for reading and this is for writing. So this is start method. So just we have used thread start is a class. Object name equal to new thread start. Call to child thread. Now we just display this one. Thread child thread equal to new thread of child reference. Child reference means this object we are calling here. So it is acts like a delegate. Always it can hold a variable address or a function address or many things. Now we can start. So it is going to hold the address of this call to child thread. Now this is going to start the thread and afterwards in main creating the child thread. Now it is going to pointing this is a process that we have to point. Now if you want that one in earlier we shown you sleep and every 1 second you can start the process or you can sleep and again continue. You will wait and it will run. One is systematically it will start. Second one is explicitly we have to start. So what method you are going to comes under threading. So it is one small piece of process. My method name is call to child thread. Now it is going to call to child thread. And this is the method is pointing with the name as child reference. And this is take it as a piece of process. So thread, process, and then you can start the thread. Explicitly, you have to start the thread. Managing the thread. Just now we have seen no? Managing means you have to take sleep for 5,000 milliseconds. Means 5 seconds. And you can pause after some time. Means every 1 second. What is this 5,000? 5,000 divided by 1,000. So here is 5. So every 5 milliseconds, you just wait and again go for sleep. After that, you can continue. So we are given one constant number for 1 second. Now it is calculating internally every 5 seconds, 5 milliseconds, wait, go for sleep, again continue. Why? Because parallel another process will be going to take place. So now we can say here that for sleep for 1 second. And sleep for 1 second. 15. Now we can upload that. Now we can make it this one inside. So first one process will start and again this process. See, it is irregularly started these threads. Every time the output will not going to become the same. So this is called as parallel threads. First with this process, meanwhile this process is stopped. Again it will be sleep, again it will be go for another process. Okay, so now how to destroy the thread. So we started with thread. Now this is thread abort exception. If you stop at the middle, it has to automatically wind up the thread. Then we can use in the try-catch block thread abort exception. If any threads are not completed fully, you want to stop at the middle, you can use it. And if you want explicitly call it, then we can use the function called as thread name dot abort. Abort is to stop the thread, to terminate the thread. Okay. So this is the thread class. So what is a thread and what is the use of it? Whenever you have many processes, without interrupting or without hanging the system or without hanging the loading the data, and you have to give some time and then you can load the data. Then at that time you can use these classes and methods. Okay. And in a tomorrow session we will see the final class, this encryption decryption with role-based security. Means till now we have used all the text-based information. We want to protect our passwords and we want to converting that one into some hash formats. And depends on the login of the user, we can access the data. Okay, that all we will see in tomorrow's session.